Well, hello, we've got another great topic for you tonight. This is called L'Hopital's rule. So how does L'Hopital's rule apply? Well, let's get this definition written out. If direct substitution of a limit yields 0 over 0, hence indeterminate, then we can apply L'Hopital's rule. So here's the notation we should be familiar with. If we take the limit as x approaches a of f of x divided by g of x and get 0 over 0, we all know that's called indeterminate. Okay, so that answer is not doesn't exist or 0. That answer is indeterminate. Then here's a method we can use. We can simply take the derivative of the numerator divided by the derivative of the denominator. Okay, so let me be clear again. Go ahead and write that out. Take the derivative of the numerator and the denominator, and here's the most important part. Do not, and I repeat, do not use the quotient rule. Now here's another big catch, so star this one in your notebook. You can repeat the process, so underline repeat the process until you get an answer that is no longer indeterminate. For example, let's say on my first limit I get 0 over 0. Then I will repeat the process until I get an actual answer. For example, if I get 0 over any number, I know that answer is 0. If I get a number divided by 0, I know that answer does not exist or undefined. Or if I just get some old number over number, I can stop. But as long as I get indeterminate, I have to keep repeating the process over and over until I get an answer. So we're going to go through about 10 examples, so please, each one's going to be slightly different. The first couple might, try to build you up, but then they're going to change on us, so please take careful notes on each one. The limit as x approaches 2 of x squared minus 4 over x squared plus 4x minus 12. So direct instinct should be try direct substitution. So I'm going to substitute this in. 2 squared is 4, 4 minus 4 is 0. So I'm going to get 4 plus 8 minus 12, and 12 minus 12 is 0. So again, I want to be clear, this is not, does not exist as a multiple choice, and this is not 0. This is indeterminate. So now that I have indeterminate, I can apply L'Hopital's rule. And L'Hopital's rule said, you're going to remain with your limit, so it's the limit as x approaches 2. But here's what we do. We take the derivative of the numerator, so that just becomes 2x, and we divide that by the derivative of the denominator, 2x plus 4. And now I take the limit again. So now when I substitute 2 in, I get 4 over 8, or 1/2. Now, some of you might have been thinking, well, couldn't I just factor? Of course you can. You can factor and cancel and simplify, but this is another method, okay? And it's going to come in real handy, especially when we do limits with trig functions. All right, so another nice, friendly, easy one here. Let's see what happens. We're going to take the limit as x approaches 1, so your gut instinct should be to direct substitution, substitute in a 1. So that's going to be 1 minus 5 plus 4, which is 0. And that's 2 plus 7 minus 9, which is 0. So again, this is indeterminate. Not 0, not doesn't exist. It means do something else. So I'm going to keep my limit, and I'm going to apply L'Hopital's rule. So when I derive the top, let's see, I get 3x squared minus 5 divided by 10x to the 4th plus 14x. Now remember, you still have to take the limit, so now let's plug in 1 again. So that's 3 minus 5 is negative 2. And what is that? 10 plus 14 all over 24. So I'm going to go with negative 1/12. So again, another option would have been to factor and cancel and then take the limit. But this is just a separate method. All right, example 3. We've seen this on our quizzes quite a bit recently. And most of you are probably thinking right away, well, I'm going to try direct substitution, but if that doesn't work and I get indeterminate, then I'm going to use, when I see this radical, I'm going to use multiply by the conjugate method. So let's see what happens first when we plug in that 3. 3 squared is 9, 9 plus 7 is 16, so I get the square root of 16 minus 4, which of course is 0, all over 9 minus 9, which is also 0. So I definitely have indeterminate. Again, not 0, not does not exist. Indeterminate, which means do something else. So I'm going to use L'Hopital's instead of the conjugate method. So I'm going to keep the limit as x approaches 3. And when I rewrite this, remember this is x squared plus 7 to the 1/2. So I definitely have an inside and an outside, so I have to use chain rule. So I'm going to go 1/2 x squared, keep the inside, to the negative 1/2, then times the derivative of the inside, all over the derivative of the denominator, which is negative 2x. Okay, and I'm going to try to clean this up as best I can. You'll notice that the 2x, because this is all one term, there's all being multiplied, it's one term, I can cancel this 2x with this 2x. So I'm going to say I have the limit as x approaches 3. I'm just going to move this negative here up to the top, of negative 1 over 2 radical x squared plus 7. And now I'll retake the limit. So I've got negative 1 all over 2 times the square root of 16, which of course is 4. So I'm going to go with negative 1/8. So again, an alternative method than the conjugate. Alright, example 4, and this is where L'Hopital's is really helpful when we start throwing trig functions in. Okay, now, the limit as x approaches 2, so I'm going to substitute in my 2, so I'm going to get 4 times the sine of 2 pi, all over 2 cubed is 8 times 3 is 24, minus 2 times 12 is 24. So definitely have 0 in the denominator. Sine of 2 pi, I'm just picturing the sine curve, and at 2 pi it's 0, and 0 times 4, of course, is 0. So again, indeterminate. So for those of you that keep asking, do we have to show indeterminate? Yes, it's imperative that that is on your paper first. All right, so I'm going to use L'Hopital's rule. Limit as x approaches 2. Now we got to be real careful here because I got to read this out loud. This says x squared times the sine of pi x. Notice I said times, and I have an x on each side. So I know I've got to use product rule. So I'm going to go first, take the derivative of the second. So it's the cosine, keep the inside, pi x, times the derivative of the inside, which is pi, plus keep the second, the sine of pi x, times the first derivative, so times 2x, all over the derivative of the denominator, so 9x squared minus 12. All right, I'm going to carefully plug in 2. So that gets me 4 pi times the cosine of 2 pi plus the sine of 2 pi times 4. All over 36 minus 12. All right, now, I actually love seeing sine and cosine in here because things tend to cancel. And again, I'm going to think of the curve for the 2 pi's. The cosine of 2 pi, when I picture the curve, is 1, so that just disappears, and I'm left with 4 pi. The sine of 2 pi is 0, so that kills that whole side completely, which is awesome. All over 24, and of course I can reduce that to pi over 6. All right, 5, we've got a very important one here. All right, so I'm going to apply my limit. I'm going to use direct substitution first, plug in my 0. So I'm going to get 0, 0. The sine of 0 is 0, so I've got my 0 on top. The cosine of 0 is 1, and 1 minus 1 is 0. Okay, so you might be thinking, what's the big deal? This looks like the previous one. Well, stay with me. So I've got the limit as x approaches 0, and here I'm going to apply L'Hopital's rule, because I have indeterminate. So I've got 2x minus 3 plus 3 cos x, all over 1 becomes a 0, and negative cosine I'm going to say is negative sine, which is going to make that a positive sign. So when I plug in 0, that's going to eliminate this term. The cosine of 0 is 1, so I have negative 3 plus 3, which is 0, and the sine of 0 is 0. Well, hold up. We just got indeterminate a second time. Well, look back in your notes. We said that we're going to have to sometimes repeat the process until you get an actual answer. So here's an example where we did L'Hopital's, we got indeterminate, and now we apply L'Hopital's a second time. Okay, so again, you might have to apply it 3 times, 4 times, but you just keep going through the process and applying L'Hopital's till you get an actual answer. So let's keep our limit as x approaches 0, and we'll take the derivative again. The derivative of 2x is just 2. 3 is a constant, so it's 0. And 3 cos becomes negative 3 sine x, all over cos x. And we'll carefully substitute 0 in, so I'm going to get 2 minus, the sine of 0 is 0, so that wipes that out. And the cosine of 0 is 1, so I get a final answer of just 2. So remember, if you don't get an actual answer the first time with L'Hopital, take it again and again. All right, example 6. So again, we'll try direct substitution first. And I'm going to rewrite this for myself and really say it's the cosine of x over 2, but it's that whole quantity cubed. Just like when we do a chain rule, a double chain rule, we have the two insides. Anytime this trig function has a power to it, we want to make sure it's outside. So when I substitute in pi, I really get the cosine of pi over 2, and it's really that whole quantity cubed. So if I picture my cosine graph at pi over 2, it's 0, 0 cubed is 0. And when I plug in pi in the denominator, the sine of 2 pi is also 0. So now I can say indeterminate. Let's use L'Hopital's rule. So just like I rewrote it here, notice I have that double chain when I take this derivative. So I'm going to say it's the limit as x approaches pi, derivative of the outside, so bring down the 3, talk it to yourself through out loud, keep the inside. Cosine of x over 2, all raised to the second. Now times the derivative of the inside. So I took care of the 3. The derivative of cosine is negative sine. Keep the inside times the derivative of the inside. Now if x over 2 bothers you, it's really saying 1x divided by 2, otherwise known as half x. Would you agree with that? So the derivative of half x is just 1/2. All over the derivative of the denominator, which again is chain, inside, outside. So derivative of the outside, keep the inside, times the derivative of the inside. And again, we'll just carefully plug in pi. I'm going to start with the bottom because it looks a little neater. Whoops, that should have been an x, sorry. So the cosine of 2 pi is 1, and 1 times 2 is 2. So there's the denominator, nice and easy. Let's see, in the numerator, I'm going to get the cosine of pi over 2. So the cosine of pi over 2, if I picture that, is 0. And that's wonderful, because if this is 0, 0 times 3 times, really, who cares, is all going to be 0. And 0 divided by 2 is not indeterminate. 0 divided by anything has a final answer of 0. Well, I hope you're having as much fun as I am with these limits. So here's example 7. Let's go ahead and plug in 0. So I'm going to get the cosine of 0 is 1. So I really get 1 minus 3, which is negative 2. So notice, what can your answer not be right away? Hopefully you said it. This is not L'Hopital's rule whatsoever. I am not getting 0 over 0. But let's finish the denominator. The sine of 0 is 0. So guess what? I'm getting negative 2 divided by 0, which does not exist. And I'm done there. It is not indeterminate, so I can't just apply L'Hopital's rule whenever the heck I feel like it. I have to first make sure I get a 0 over 0 to use L'Hopital's rule. If I don't get it, then I just have an answer in front of me. So this L'Hopital's rule did not apply here because I did not have indeterminate, which means anybody divided by 0 does not exist. Well, we're going to get a lot of great practice in class tomorrow, and we'll look forward to seeing you. Have a great night.